At the end of chapter 3.3, we want to piece all of this together, the idea of slope, intercepts, slope-intercept form, right, to finally be able to graph a line a different way. We saw in 3.2 how to graph a line just by finding random solutions, or maybe very specific solutions, the intercepts. Right, but right now we're going to find a different way to graph a line, and this is one of the nicer ways to graph a line, and if we could do it this way, I think it's preferred. But I'll let you be the judge of that. All right, so if we want to graph a line with a specific slope and y-intercept, well, let's look at an example here. Right, let's say y equals 4x minus 1. All right, so first, we would need to find the slope and y-intercept, so it would be great if we had, we need the equation in y equals mx plus b form. Right, which in our example it is, y equals 4x minus 1. We're good to go, we like that. So if it is in that form, that means first we can identify the slope and the y-intercept. Right, looking at our example, our slope would be, right, remember, m is our slope, so that's the coefficient, so our slope is 4. I'm going to write it as a fraction though, because we're going to want to graph it, so I'm going to think of it as a rise and a run, 4 over 1. Right, and the y-intercept, it's a point that will always start with an x-coordinate of 0, and it's our trailing constant, which happens to be -1. So, slope of 4, y-intercept of -1. So we identified them. Here we have it. How can I use those to graph this line? All right, what we're going to do is we're going to plot the y-intercept. All right, that's always going to be your first move for graphing. It's the only point that we know is on the line. We don't know any other locations, so we have to start here. I'm going to call this my starting point. All right, so going over here, we can do that. All right, let's draw a little graph. All right, it goes to 4 and -4 and positive 4 and -4. Right, if I'm going to start on my y-intercept, right, notice this is always going to fall on the y-axis if it's my y-intercept, so it's going to be starting at -1 right here. Here's my first point. And then to finish this line off, right, from the y-intercept, right, so we're still standing on the y-intercept. This is our location. Right, so some people make the mistake of going back to the origin and doing this next step, but always start on your y-intercept. So from the y-intercept, right, follow your slope. Follow the slope. And when I mean follow the slope, I mean think of it as a rise and a run. Right, this is a set of directions on how you get to the next point. So follow the slope to plot another point. Right, once you have 2 points, you can connect those points and have your line. I'm going to do 3 points though, just so you can see. Let me make this go down one step further so I can show you both directions. This goes down to -5 now. All right, so if I wanted to graph this line, we could start at this point. All right, since both of these are positive, I'm going to go on positive directions. So if I was starting at this point, I would need to rise 4. I'll do this in a different color. You don't need to draw this in, but it's a good visual. Rise 4, so I'm going to go up 1, up 2, up 3, up 4, so I'm 4 steps up. And then I run 1, that's a positive, so I'm going to run 1 to the right. And at the end of that, there should be a point. And if you connected these two, you'd have your line. But I'm going to go one step further than that. We went +4 and +1. Perfectly legitimate, and I would expect you to go that way. But just to point out, you can also go the opposite direction. If you wanted to go the opposite direction, I would need to go the opposite of both of these directions. Since these are both positive, I could go negative for both. If I started at this point, and instead of going up 4, I chose to go down 4. Right? Seems like a peculiar thing to do, but we could go down 4 as long as we also went the opposite direction in terms of run. Instead of going to the right one, I would have to go to the left one. So we did the opposite 2 directions, which is fine. And if we go down here, plot our point, notice all 3 points still fall on a line. So it's a good way to get 3 points. Again, you do not need 3 points to graph a line, you only need 2. But it's a good comprehensive way to talk about slope. You should know that you can go exactly the directions it tells you, right? Positive and positive, or you can go the exact opposite, negative and negative. All right, let's try this one more time with another example. All right, one that's a little more complicated. So here's an equation, negative 4x minus 3y plus 5 is equal to negative 1. Right, not the nicest looking equation, and it's certainly not ny equals mx plus b form, so that's where we should start. If I'm going to graph it using a slope and y-intercept, I need it in this form. Right, so we need to solve for y. That would mean getting rid of all the terms that are around y. Right, I'm going to start off by eliminating this constant term, so since it is positive 5, we can add a negative 5 to both sides to start this off. All right, that'll cancel out my constants here. These two can group together. They're both constant terms. That's a negative 6. Negative 4x minus 3y still on this side. All right, progressing, we're getting closer, but this y term still wants to be by itself, so this negative 4x. All right, let's add a positive 4x to eliminate it. Make sure we do that to both sides of the equation. We have negative 3y is equal to, okay, now these two do not group together. Variable term, constant term. So we have a positive 4x and a negative 6. All right, finish this off by dividing by this coefficient exactly. All right, every term gets divided by negative 3, and we have y equals 4 over negative 3x. Negative divided by negative would become positive 2. Now we have that equation of a line. Had to do a few steps, preliminary steps, to get this into a nice form, but once it's there, we can jump straight to the graph. Okay, I'm still going to identify what my slope and y-intercept are. They're my slope coefficient, 4 over negative 3. Y-intercept, 0, 2. Alright, so 1, 2, 3, 4, 5, 6. Alright, so I only put this up to 6 because you'll see in a second, we're going to need to go up that high. All right, if we wanted to graph this line, all right, we start, as always, with our y-intercept. So I'm going to plot that first. That's my starting point. All right, and from this starting point, I can follow my rise and run. All right, so notice this rise and run. My rise would be positive, so I'm going to have to take 4 steps up. 1, 2, 3, 4. That's why I needed a 6 up here. And let me move it out of the way though. Alright, it needs to be out of the way because my run is now negative 3. Since it's negative, that would mean I need to travel in the negative direction. So to the left, 1, 2, and 3. Here is another point on my line. Clearly this is going to be the line, but just to show you again, right, that this slope can be thought of in reverse as well. If I went up 4 and to the left 3, that's exactly the same as traveling the opposite direction in both. So instead of going up, if I chose to go down, 2, 3, 4, right, that would mean that I also have to do the opposite down here. So instead of going left 3, I could travel to the right 3. Here's another point on my line. Right, these 3 points should be all nicely connectable, and we have a good picture of our graph. Right, so this skill is going to be very important going forward. Right, not only in 3.4 and 3.5, but also in chapter 4, we're also going to need to be able to graph these lines. Right, and slope-intercept form is the nicest way, I think, to do it.